two unique passes from LeetCode. Let's jump to the question. The question is saying there is a robot on M by N grid, and the robot is initially located at the top left corner, as you see here. And the robot tries to move to the bottom right corner to here, and the robot can only move either down or right. So we can go either down or it can go right? So given the two integer M by N, return the number of possible unique passes that robot can take to reach the bottom right corner, right? So the question is saying, okay, a grid is given to us, which is going to be only two numbers, M by N. So we have a like 3 by 7 grid here in this example, and we should find out about the number of unique passes that we can take from index 0 by 0 to index m minus 1 n minus 1, right? So we should find the number of possible passes that we can take. So based on the information that is given to us, we can go either down or right? So for, let's see what are the possible like unique passes that we can take. We can go all the way right and down, this is one pass, or we can go all the way down and right, and this is another pass, or we can go right and down and right and down, or we can go right and down and right and down, and so on. So there are too many different passes that we can take to reach to this point. And as you see, the output that we need to give is just a number. We just need to know the number of unique passes. So let's go through some examples and the code and see how we can solve this problem. So let's try different like combination to get better grasp the concept. So the grid that we have here is 2 by 2, right? It's 2 by 2, and the number of passes that we can take to reach out to this point is one from here, or we can go either from here. So we can have two different unique passes to reach out to this cell, right? How about this one? This is like 3 by 2 grid, and we can take either this pass from here to here, or we can take this pass from here to here, or we can take this pass from here to here. So we have 3 possible passes that we can take. How about like 3 by 3? So as you see, we can take a few different passes to reach out to this cell. And what we can see from here, it's a pattern that we can see it keeps repeating. And the pattern is repeating is like what we know, we in the first row and first column, there is only one path to reach out the next cell. So if I want to go from this cell to this cell, there is only one path that I can take. How about from this cell to this cell, based on the information that we have, that we can go only right and down. We cannot go any other way. We cannot go up or left. We can just go right and down. So there is only one path from here to here. And how about the first column? There is only one path from here to here, and there is only one path here to here. So how about the other rows? From to get to this point, we can take either this path or this path. So it's not just one path that we can take. Or like for the rest of the grid, there are different paths that we can take to reach out to them. But for the first column and first row, we can take only one path. How can we use this pattern to calculate the number of unique passes? So for doing that, we are going to use dynamic programming. How can we do that? We are going to define a grid which is m by n, right? We have m rows and n columns, and we're gonna fill it with all one. So let's do that. So we're gonna, let's say in this example, we are doing a grid 4 by 4, and we're gonna fill this grid with all one, right? So we're gonna fill it with m by n grid with all one, right? So it is filled all with one. So this is going to be something like this. The output of this line is something like this. As you see, we have n columns and m rows, right? So let's see how we can calculate the number of unique passes to each cell. So as you see here, if we consider the cases that we already went through, so for getting from here to here, we can take two different passes, right? These are the passes. But if I sum these two numbers, it's gonna be 2 as well. So is that something that I can use to calculate the number of passes that and the number of unique passes to reach out to this cell? Can I use that? Let's see if we can use that. So like we can sum up these two and it's gonna be 2. Okay, that's correct. And sum up these two, it's gonna be 3. And and 3 is the number of unique passes that we can take to reach out to this cell. So it worked for these two cases. How about this one? So sum of these two is gonna be 2. Sum of these two is gonna be 3. Sum of these two is gonna be 3. Sum of these two is gonna be 6. And 6 is the number of unique passes that we can take, and that's the right number that we need to get out of this. So let's use this pattern to calculate the number of unique passes to reach out to each every single cell. So what we are going to do, we are going to start to iterate through this grid, but because we already know there are only one single unique pass that we can take to reach out to every single cell in the first row and the first column, we can avoid the first row and the first column and just iterate through this part of the grid. So we can eliminate the first row and the first column. And to do that, what we are going to do, we are going to start from the second row, which is because it starts from 0, it's going to be 1. And the first column, which is going, because it starts from 0, is going to be 1 as well, right? So let's do that. So let's iterate over this grid and replace all the ones with the new number, which is the number of unique passes, right? So let's do that. So let me just assume that we're gonna just replace them, right? So let's start at we start at 1 and 1, right? So it says sum of these two should be put at here. So we're gonna do that. And now for these two, we're gonna put 3. For these two, we're gonna put 4. The next row, we're gonna put 3 here, we're gonna put 6 here, we're gonna put 10 here. We're gonna put 4, and it's gonna be 10, and 10 plus 10 is gonna be 20. So the number of unique passes is gonna be 20, and this is what we are going to return at the end, which is going to be the last row and the last column. And the time complexity for this solution is going to be O(m) by n, because we have m rows and n columns, which we are going to iterate over. And the space complexity is going to be m by n too, because we are going to use dynamic programming, which is the grid that we are building at this point. Thank you.